Um, Good morning, ladies and gentlemen. My name is Nomanya Joel, and together with my teammates, we are working on a project, Mobile Acoustic Intelligence for Privacy Preserving Clinical Audio AI for Cardiac Decompensation in shared words. So what we're talking about here is the project is focusing on artificial intelligence systems that can classify heart systems, but while preserving the patient's privacy, especially in resource constrained hospital environments. So now what I'm going to take you through is the specific project that we are working on is automated classification of heart sounds to detect pathological patterns. So this is what my groupmates and I have come up with, and our conventional problem is that we we input raw data using the heart sound analysis, and then we get feedback as categorical labels, so as categorized as normal or abnormal depending on the condition of the patient. So our objectives, of course, we have to develop a robust model that achieves high F1 score, because we know that the system we're working with is uh, is very sensitive. The medical sector is very sensitive, and if we have a very small margin of error, leaving out some data, it can cause loss of lives of people, and here every life is important. So of course the learning paradigm we are going to use is supervised learning. This is because we're using medical labeled data to train our AI model. So we began with data collection. Data collection, we had two data sets, one from SQL, the DigiScore, and the other from the PhysioNet 2016 challenge. So the SQL DigiScore dataset that we used was mainly for pediatric patients. That is ages 0 to 21 or 0 to 20. Data collected for the patients included murmurs, and it's presenting three categories: whether present, absent, or unknown. So this is very suitable for supervised learning since the data collected is labeled. Then the second data set that we had was the PhysioNet 2016, and this came in handy in the age groups because it covered a larger amount of ages. But however, most of the data that we are collecting from this data set contained significant noise, which was making it harder for the model to interpret. So what we finally went with was the first initial data set, which is the SQL Digiscope, and this is because of course the clinical relevance, which is collected in real screening campaigns, which aligns closely with our hospital use case. The the quality the quality of the data, it had less noise compared to the other data set, and of course the manageable complexity that it's focused on the point to build a proof of concept system before tracking noisier data. Then went further ahead to do the exploratory data analysis, the EDA, and this is where we have the data structures and the features. We found 942 patients with 23 features, and then categorized the variables, but also numerical ones like height. We had the categorical variables, but also had the numerical variables. Target variable was the mama, where it has three possible values. It can either be absent, present, or unknown. So what we went with is that we went further ahead to find the missing values and the data cleaning. This is all that happens in the EDA. This is all that takes place in the EDA, because we have to make sure that if there are missing values, then the missing values the rows that have missing values are removed. Then also we have to make sure that where the mama was unknown, the rows are also removed and we focused on the core features such as sex, age, height, and weight. Then we dropped, of course, the values.
Hi members, my name is Yohana Muhammad. I'm the second member. I'm going to present the basic descriptive statistics. Here you have the dataset overview, which contains the total number of patients are 759. Then the features are 5. The first one, you have the numerical features, descriptive statistics, which has the weight and the height. Then you have the third point, which is categorical features, descriptive statistics, which contain the age distribution, sex distribution, mama distribution. The other point is additional statistics. After you have the correlation analysis, which you have a strong positive correlation, it gives us 0.856. Then you have the missing value in the final data set. In our final data set, we are seeing that you have 0 missing value. All missing value have been handled in the cleaning process. Then here you have the visualization and insight. In the visualization and insight, you have the first point is target variable distribution. Here you have two people with and without the mama. So we can see the people without the mama are more higher than people with it, which represents 78.4%, and Arab represent 21.6%. Then you have the age group distribution, which you can say that more patients are represented by children. Then you have the sex distribution, height distribution, and weight distribution. The sex distribution, we are seeing male are more higher than female. Then in the height distribution, just showing the frequency with the height. Then the other point for the weight distribution, you have the frequency and the weight, which you can say that is decreasing. Then you have the correlation head map. In our correlation head map, the height and the weight are strongly correlated according to our correlation. Here you have the scatter plot for height versus weight. So here you have a strong positive correlation. You don't have a negative correlation. So then you have here the model fitting and evaluation. So for the first point, the model selection, you selected random forest classifier. Why this model? So you choose this model because it handles mixed data types well, is a robust to overfitting through ensemble learning. Then it provides feature important for interpretability. Then the second point, which is mode architecture and parameters, you have the algorithm random forest, ensemble of 100 decision trees. Then key parameters, you have estimators, which is 100, class weight is balanced, random state 42, training sets 607, the text set is 152. Then you have the third point, which is evaluation metrics and rational. In the evaluation metrics and rational, you have primary, you have secondary, additional. Then for the fourth point, which is results and interpretation, here you have A1 score 0.160, which is poor performance for mama detection, accuracy 0.724, which is misleading, reflects majority class prediction. Then you have the precision, which is 0.24, low, many false positives. For the 5 limitation in time, you can say demographic features alone are insufficient for accurate mama detection. Model differs to predicting majority class due to imbalance. Then the audio features would be essential. Demographic data lack predictive power. The last point is clinical deployment would be dangerous with current performance. In the conclusion, this exercise demonstrates that hard mama detection requires audio analysis rather than demographic data alone. Here, that is the next part of the model fitting and evaluation. Here we have the complete pipeline, which is data loading with the model training. You have the loading of the data. This is the original data set which contain 942. Then the data cleaning, we did the data cleaning well, that gave us 759. Then the class distribution, absent represented by 595, then the present is 164. The data preparation, you have feature matrix shape, target encoded, then you have the data splitting and scaling. You have the training set, which is 607, then you have the text set 152. For our model training, the model training is well completed, which is here showing. Then you have the model evaluation for the classification report. You have precision, recall, F1 score, support. You have absent, present. Then you have accuracy, which is macro average, weighted average. Yeah, that is also another graph for our model fitting and evaluation. Thank you.
So hello everyone, my name is Dafoka Jeffa Kevin. So today I'm gonna talk about integration of core AI concepts. So the first thing we have learning paradigm. Supervised learning, use labeled data, murmur, present and absent. So the problem require learning from expert annotated examples to classify new unseen cases. Then in the second part you have the type of intelligent gardeners. Naturalistic intelligence, the model learn pattern in the human physiology of the heart. Then you have a logical mathematic intelligence, statistical, pattern recognition and features analysis. Then the third point we have the data meaning approach. Yeah, it's the classification, primary task, binary classification, present versus absent. The anomaly detection, murmur, the detection as identifying abnormal physiological patterns. So in the fourth point we have knowledge, representation and reasoning. The feature embedded, numerical representation of the physiological features. Probabilistic reasoning, the model output probability score for each class. The rule based insights feature, important reveals pattern like higher weight correlate with murmur. So here we have the model section and deployment. The random forest, here the reselling the noise, model less sensitive to noise data. The high accuracy to combine multiple decision tree to improve accuracy. The deployment friendly and interoperability, easy to explain to stack a lot. Focus on error, there's the second one we have the GCC. Focus on errors, the probability related prediction. This provides a more honest decision making procedure. So you have the deployment on Android mobile phone to aid the patient with the heart disease to check on his health. So attached to a low cost, the microphone to reduce the noise interception. You have noise also suppression with the noiser and spectral subtraction to reduce noise in the data collected. So you have the users of GCC, FAT, time difference of arrival and MVDR/GAV. The extra cardiopulmonary biomarker plus CNA, transformers classifier to group data. So in the demonstration of the developed product, the user interface. So here, like the patient has to put his data there. Then you can also the result predict his result, display his result in a real time. So we have the prediction section. He can also put his data and check on his status of health. Okay. So you have the multiple layer of AP, front end and back end of the API server configuration. So now in conclusion and limitation. In conclusion, the system successfully predict the patient outcome in real time. New model easily integrated into the system without much needs or redesign. Front end is user friendly and easy for patient to use. So in the limitation there, we have limited data for training the model throws limiting accuracy. We require the high quality data, thus making it difficult. The maintenance need retaining of the model over time. So thank you.